Okay, so welcome to this review screencast of the 6 weeks test centroids problem, which was this complex shape involving this rectangle topped by a triangle. So we're just going to dive right in. A number of people had big challenges with this, and a few of you tackled it successfully. But for those who didn't, or who would like a review, just follow along. I am going to solve this problem while I talk you through it. Hopefully you read the entire thing here that tells you that a complex shape is given below using these dimensions that are all marked on both of these shapes. Calculate the area and the centroid of the rectangle at the bottom and the triangle at the top. Then the area and the centroid of the entire shape as a whole, which is the goal. We want to know where's the centroid of this complex shape. And so the basic approach is divide this shape into the simplest shapes we can, which we can form two triangles, or one triangle on the top and a rectangle down below. And then the location of each centroid, this is the key right here. The location of each centroid should be stated in relation to the given x and y axis, which we found the origin down here in the bottom right hand corner. So we're going to look up here first. This table right here is asking us to find the x-coordinate, the horizontal component of the complex shape's centroid. In other words, along the x-axis, how far along will we find the centroid of this complex shape? And then down below, we have a similar table to help us find the y-coordinate. And if you look at this table, it tells us all the information we need and the math that we need to do in order to calculate this ordered pair, the x and the y location of the centroid for the complex shape. The A, as you might imagine, stands for area. And so in this column right here, we're looking for the area of both the bottom rectangle and the top triangle, at which point then we're just going to simply add those two numbers together. In this column, it's asking us what is the x location for each shape, the centroid of each shape. So here we'll put the x location for the bottom triangle, and here we'll put the x location for the for the rectangle, and here for the top triangle. In this column, there is some simple arithmetic where we multiply the area times the x location, and then do the same thing for both shapes, and then simply add them up. When we've completed this table, we can go to our statics reference sheet and be reminded that if we want to find the x location, we take the sum of these products and divide it by the sum of the areas. So while it looks complex, it's just quite a number of steps. So you have to go back and do some geometry. We see that the base of this rectangle is 9 inches. The height is 4.5. We just multiply those two together, and 9 times 4.5, if you do that on your calculator, is 40.5. And so we simply enter 40.5 as the area that the units are given to us here as inches squared. We're going to come down and do the same thing for the top triangle. We have this triangle that has a base of 9 inches and a height of 4.5. And if we recall, the area for a triangle is 1/2 base times height. So we just do that on our calculator. 0.5 times 4.5 times 9 equals 20.25. Now we'll come down here and simply add those two numbers together. We can do that in our head, 60.75. And feel free to confirm that on a calculator if you'd like. Now here's where we have to do a little more thinking. Look at the x-axis, and let's start with a rectangle. We know a rectangle or a square has its centroid at the very geometric center. So all we have to do is divide for the x-axis, divide the base divided by 2. And we can do the same thing with the height. So the the x location, 9 divided by 2, 4.5. Come over here, and then the top triangle, we have a little bit of a different calculation to make. If we want to find the x location of a centroid, we just simply need to take the base and divide by 3. So we come back over here and we see that the triangle has, once again, a base of 9. Excuse me. And if we divide that, oops. So we'll continue finding the x location of this triangle here, which if we look, they share the same size base of 9 inches. So all we have to do is move along the x-axis halfway, and we go up, and we know the centroid is going to be located along this line of symmetry. So it also is 4.5 inches. Now we come over here and do some simple math. This is simply asking us to multiply the area times the centroid location for the rectangle. So if we multiply 40.5 times 4.5, 4.5 times 40.5 is 182.25. Come down to the same arithmetic, 20.25 times 4.5, 91.125. In this column, all we have to do is add these two numbers, 182.25 plus 91.125. And the answer we get, 273.375. Now we're left to do this simple math, which asks us right here to divide that sum by the sum of the areas. So we come back over and we take 273.375 and divide it by 60.75 to get our final answer for the x location of the centroid is 4.5 inches, as we might have been able to determine on our own. So while we know on the y location, well, the centroid of the triangle is going to be up in this area, and clearly we know that right here, the centroid is going to be here for the rectangle. It's got to be somewhere along this line here, somewhere probably in this area, but we know the x location is at 4.5. So we're going to come down here now, do the exact same procedure for the y to find the y coordinate. And we know we've already done this math. The area doesn't change for the rectangle, nor does it change for the triangle. So all we have to do is copy those numbers back in there. And here we go. Now, if there's a hard part, here it comes. We need to find the y location of the bottom rectangle. So we just go halfway up the x-axis. Half of 4.5 is 2.25. Now, the triangle, this is the trickiest part of the whole problem. We need to go not just up here and use a new origin. We're going to start right here and go, this is 4.5 inches. And then my reference tells me right here that the y location of the centroid for a triangle is 1/3 of the height. So I just move myself back over here and go 1/3 of the height here is 1.5. So 1.5 plus 4.5 is 6. So all we have to do is plug in the number 6, come do some math. 40.5 times 2.25. 2.25 times 40.5 equals 91.125. Once again. Then we take the top triangle, 20.25, multiplied by 6 equals 121.5. And then we simply add those two numbers together. 91.125 plus 121.5 equals 212.625. Now we have one final step. We can take this number, divide by, as our reference tells us, we want to find the y location of the centroid, take the sum of this product divided by the sum of the areas, and lo and behold, 3.5 is our answer. We want to go check that and see if it makes sense. So let's look. If we go up 3.5 inches, that would put us right around here, which is above the rectangle and below the triangle. And to me, that makes sense. So I can go back and make sure all my numbers are correct. And if I hit submit, we'll see how we did. And look at that. I got 100. You better hope so. It only took me 13 minutes, and that included a bunch of talking. So I hope that helped you. And there will be another example practice problem that I will talk you through. And then if you want to take a retake, there will be an additional problem that will allow you um, to improve your score on this part of your 6 weeks test. So hope you found that helpful. Good luck.